class and hope you're having a good day. Today we're going to take a look at review for test, which is our last topic of this unit. It's just a review of everything, so it should be nothing new. It should just be a summary of everything we've learned in terms of our quadratic functions. Okay, so taking a look at our first topic, quadratic functions. How do you find the vertex? Well, first of all, you have to take a look at what form the quadratic is given in. So the first one here, taking a look here, this is in factored form. So in factored form, ladies and gentlemen, it gives us the zeros, okay, which are R and S. Okay, just remember another word for zeros could be roots, it could be solutions, or it could be, if you have a graph, the x-intercepts. Okay? All right. How do we then find the vertex? So number one, once you know your zeros or your roots, you use the formula r plus s divided by 2. This actually gives you the equation of the axis of symmetry. And then after you find that value, 2, you're going to sub the x value into the function to find your y value, and then you'll have your vertex. Oopsie, sorry, spelling mistake. Back that up. All right, so just to review, guys, when you have factored form, find your zeros, which is the opposite of what's in the brackets. You add those two up and divide by 2 to get your axis of symmetry. So this is your axis. And remember, your axis, ladies and gentlemen, is also the x-coordinate of your vertex. So then you sub that x value into the function to find the, apologize for the spelling mistake there, the y-coordinate. Then you have your vertex. Okay? The next one, take a look at the next expression. This is actually in vertex form. This is easy because guess what? The vertex is given to you. So it gives you the vertex right away. And the vertex is your D and C values. Okay? And just remember, these both tells us important information. So x equals D is your symmetry line. Okay, or the axis of symmetry, whereas the y part gives you your min or max, or what we call optimal value. All right, so again, this is your axis and your min, max, or optimal value. That's the easiest form to get your vertex from, gang. All right, and the last one, ladies and gentlemen, is when you're given standard form. Okay, so standard form is the hardest one to give you the vertex because it gives you the y-intercept. Okay, and the y-intercept is the c value. Okay, and how do you find the vertex here, ladies and gentlemen? Just remember, you need to complete the square to get the vertex. Good. All right. Sorry, just missed my quotations there. Now, next one. It says, remember that each form gives you the A value. This is important because it tells you A, direction of opening. Okay, which also will tell you if you have a minimum or a maximum. Okay, and what's useful when we're graphing, it tells us the step pattern. Okay, which is A times 135, which tells us if we have a vertical stretch or compression. That's embedded in your step pattern. All right, good. Now we're going to deal with min and max values. Okay, So when a is greater than 0 or a is positive, there's my short form, the parabola opens up. Therefore, there is a minimum. Likewise, if a is less than 0, it's negative. That means it opens down. And if it opens down, there is a maximum. Okay? The y coordinate, and that's important to remember, of the vertex is your min-max or optimal value. Okay? If you're in factored form to find the vertex, remember it says up there, how do we find the vertex? You take x, which is r plus s, divided by 2, and then you simplify it. And then your second step is to sub x into the function to find y. It's very important that you do that. That's why we wrote it down twice. Okay, and the third one, ladies and gentlemen, for third form, if you're given quadratic formula in standard form, you're going to complete the square. Don't forget your two quick steps here. One, factor a out of the first two terms. And then second one, remember you're taking the margin, b divided by 2, and you square it. And then 3, complete the square. And you're given your vertex. And just remember, folks, for number 2, just to do that in the margin. Please don't make it part of your regular solution. It just destroys the flow of your equation. All right, next we did something kind of new, which is called radicals. And to simplify, you have the smallest numbers under the root. Okay, so you try to change any entire fraction or radical, entire radical to a mixed radical. Okay, and in order to pull numbers out, the factors have to be perfect squares or cubes, depending on the question. So taking a look, and again, you can use your matrix, which should have your square roots symboled highlighted on them. If you're not sure what that means, come and see me and I can help you with that. Okay, you could use that for your test. So what we need to do is take a look. 5 is our whole number, but how can we break 75 into two factors where one is a perfect square? Well, it's 25 times 3 under the root. Then we recognize that 25 is a perfect square. So when you take the square root of 25, that's 5, but we already have 5 here, so it's 5 times 5, which equals 25, and the root still left over is root 3. All right, taking a look at our next example, ladies and gentlemen, be careful here. It's a cubic root. It's not a square root, so you can't use your times table, which has square roots highlighted on the diagonals. You've got to use your cubic list. Okay, so you should have a cubic list somewhere that has 1, 8, 27, 64, 125, and I think it's 216. Okay, we shouldn't have numbers bigger than that anyway. All right, so taking a look at that, I noticed that I have 6 times the third root of the smallest number that goes in is 8 times 3. Okay, and this is where you've got to be careful. When you bring the cubic root of 8 out, it's going to be times 2, and we still have root 3 left. So your final answer here is 12 to the cubic root of 3. Okay, and that sign needs to carry in each line. All right, D. The biggest thing that we talked about when we're solving quadratics is you try to factor first. If you can't factor, then use quadratic formula. The rule of thumb, ladies and gentlemen, is spend 1 or 2 minutes to see if you can factor. If not, use the quadratic formula. I will either write that on the test or I will put it on the board for you. You don't need to memorize it, but many of you I know already have. Okay? Next, we took a look at the number of zeros, and we learned a new term called the discriminant. Okay, and that's the value underneath the square root sign in the quadratic. So that is your b squared minus c equals, b squared minus 4ac. Okay, and if that value under the square root is greater than 0, that will tell us we have 2 roots. If it equals 0, you will have 1 root, and if it's less than 0, you will have no roots. Okay, some questions ask for the k values. Okay, so just remember that when you're looking for k values, those aren't actually your roots. Those are just the numbers that you will sub in. Okay, so you choose one of these equations depending off if it says if it's got 2 roots or 1 root or 0 roots or x-intercepts or solutions, and then you allow yourself to deal with an inequality or an equation. Just remember, guys, when you're solving for k and you've got an inequality, remember the rule when you multiply or divide by a negative. It flips the inequality. So a greater than becomes less than, or a less than becomes greater than. All right. And the last topic that we learned was dealing with linear versus quadratic systems. And when you're dealing with it algebraically, you let f at x equals g at x. Okay, so you rearrange it so that you've got 0 on one side. To solve, you either factor or use the quadratic formula. And if you're asked to find the number of solutions, okay, that should not say zeros, number of solutions. If you could change that, that would be great. Okay, to use the discriminant. And then again, you could ask for k values for certain values to choose to sub in. All right, so there's a summary, ladies and gentlemen. Just remember, for quadratic and linear systems, you could either have no intersections or no point of intersections. You could either have one intersection where you've got it either hitting the vertex or a vertical line, or, ladies and gentlemen, you could have where you've got your 2 solutions or 2 points of intersection. Okay, so those are your 3 possible cases for when they ask you for the number of solutions. Okay. All right, there is a review, ladies and gentlemen. Hopefully that's helpful for you. Now you're going to do some practice, ladies and gentlemen, on page 202, numbers 1, 2, 4, 5, 9, 10, 12 to 17, 21, and 22, and some extra practice. You can see page 170 as well as 204, but on 204, please omit number 5. Simply is not something we deal with our curriculum anymore. All right. Have a great day, folks. Get ready for your test. And again, come see me if you have any outstanding issues. And let's have great success on our upcoming test. Have a good day.